Hello, welcome to another maths class. My name is Manuela Ndiemu, and today I'll be taking you on the second part of the topic trigonometry under the theme mensuration and geometry. By the end of this lesson, you should be able to solve problems on applications of trigonometric ratios to finding distance and lengths. And you should be able to apply trigonometric ratios in solving word problems. Now recall that in the first part of this lesson, we learned all about the three trigonometric ratios for the sides of the right angle triangles. We learned that they are sine, cosine, and tangent. We also learned the mathematical expressions for these trigonometric ratios. We learned that sine theta is equal to opposite side over hypotenuse. We learned that cosine theta is equal to adjacent side over hypotenuse. And we learned that tangent theta is equal to opposite side over adjacent side. Now, to help you remember the mathematical expressions for the trigonometric ratios, we use the abbreviation SOHCAHTOA. First, we have SO, which stands for sine is opposite side over hypotenuse. Next, we have CA, which stands for cosine is adjacent side over hypotenuse. And finally, we have TOA, which stands for tangent is opposite side over adjacent side. Now note that trigonometric ratios are only applicable when we are solving for right-angled triangles. Now sine, cosine, and tangent of angles can be used to find the length of unknown sides in a right-angled triangle. If you are given the length of a side of a right-angled triangle and the angle, it is very possible to find the length of the other sides of the right-angled triangle. Now let's take a look at some examples. Example 1. Calculate the value of x in the right angle triangle below. Now step 1, we identify the given sides of the triangle and the given angle. Now in the triangle, we were given the hypotenuse to be 20 centimeters. The opposite side is x and the angle given is 30 degrees. Step 2, with the sides given, figure out which trigonometric ratio can be used. Now you can see that we have the hypotenuse and the opposite side. So if we go back to SOHCAHTOA, we will know that the trigonometric ratio to be used is sine, because sine is equal to opposite side over hypotenuse. Step 3, we substitute the values given into our equation. So this will give us sine 30 degrees is equal to x over 20. Step 4, we solve the equation. Making x as subject of formula, we take 20 to multiply sine 30 degrees. This will give us 20 multiplied by sine 30 degrees is equal to x. Using our 4-figure table or a calculator, we'll find out that sine 30 degrees is equal to 0.5000. So it will be 20 multiplied by 0.5 is equal to x. 20 multiplied by 0.5 will give us 10, which is equal to x. So this means that x is 10 centimeters. So you can see that when we are given the length of a side of a right angle triangle and the angle, we can find another side of the right angle triangle. Let's look at another example. Find the value of x in the triangle below and give your answer in two significant figures. So our first step, we identified the given sides of the triangle and the given angle. We were given adjacent side to be 70 centimeters, opposite side to be A, and the angle given is 25 degrees. So now with the sides given, we will figure out which trigonometric ratio can be used. We were given the adjacent side and the opposite side of the triangle. So our trigonometric ratio will be tangent because tan theta is equal to opposite side over adjacent side. Step 3, we substitute the values given into our equation. This will give us tan 25 degrees is equal to A over 70. Step 4, solve the equation. Now making A as subject of formula, we take 70 to multiply tan 25 degrees. This will give us 70 multiplied by tan 25 degrees is equal to A. Using our calculator or 4-figure table, tan 25 degrees will give us 0.4663. So this will give us 70 multiplied by 0.4663 is equal to A. 70 multiplied by 0.4663 will give us 32.641, which is equal to A. Now we have to give our answer in two significant figures. So rounding up 32.641 to two significant figures will give us 33 centimeters. Having looked at those examples, we can also apply trigonometric ratios when solving word problems. Now, when solving word problems, it is important to understand the problem first before you begin to solve the problem. Now, when we are given a word problem that has to do with trigonometric ratio, it is important to represent this problem with a diagram to make it easier for you to understand. Now, let's take a look at an example. A ladder 5 centimeters long leans against a wall so that it makes an angle of 60 degrees with the horizontal ground. Calculate the distance between the wall and the ladder. Step 1, we understand the problem and represent it with a diagram. Now, a ladder 5 centimeters long leans against a wall. Let's say we have a wall here, and this is a ladder leaning against the wall, which is 5 centimeters. It makes an angle of 60 degrees with the horizontal ground. This is our horizontal ground, so this angle is 60 degrees. We are to calculate the distance between the wall, that's here, and the base of the ladder. So we have to find this distance. So this is our diagram. Step 2, we identify the sides given in the problem. So from the diagram, you can see that we have the hypotenuse, which is 5 centimeters, and the angle given is 60 degrees. We are to find the adjacent side, which is the distance between the base of the ladder and the wall. So we will name our adjacent side y. So with the variables given, we figure out which trigonometric ratio should be used. We have our hypotenuse and we have the adjacent side. So the trigonometric ratio to be used is cosine, because cos theta is equal to adjacent side over hypotenuse. Step 4, we substitute the values given into our equation. This will give us cos 60 degrees is equal to y over 5. Step 5, we solve the equation. Making y as subject of formula, we take 5 to multiply cos 60 degrees. This will give us 5 multiplied by cos 60 degrees is equal to y. Using our calculator or our 4-figure table, we will find out that cos 60 degrees is equal to 0.5000. So this means 5 will multiply 0.5 equal to y. 5 multiplied by 0.5 will give us 2.5, which is equal to y. So this means that the distance between the wall and the base of the ladder is 2.5 centimeters. So with that example, we have come to the end of today's class. But before we go, let's take a look at a quick summary of all that we have learned so far. First, we learned that trigonometry is a branch of mathematics where we study the relationships between sides, angles of triangles, and their measurements. We also learned that to help you remember the trigonometric expressions, we use the abbreviation SOHCAHTOA. Next, we learned that sine, cosine, and tangent of angles are used to find the length of unknown sides in a right-angled triangle. We also learned that we use 4-figure tables or calculators when finding out the sine, cosine, and tangent of angles. And finally, we learned that we can also apply trigonometric ratios when solving word problems. Test time. Question 1. The angle of elevation of the top of a building is 30 degrees from a point 20 meters away on level ground. Calculate the height of the building. Your answer should be given in two significant figures. Option A, 10 meters. Option B, 15 meters. Option C, 12 meters. Or option D, 14 meters. The correct answer is option C, 12 meters. Question 2. Find the value of Z in the triangle given below. Option A, Z is equal to 3.46. Option B, Z is equal to 3.56. Option C, Z is equal to 3.76. Or option D, Z is equal to 3.86. The correct answer is option A, Z is equal to 3.46. Thank you for your time. I'm sure you can now solve problems that are related to trigonometry. Till we meet again, bye-bye.